Classification loss functions. In the last few lectures, we were looking at regression loss functions. Now we are done with regression loss functions and we are moving on to classification loss functions. What is the difference between classification loss functions and regression loss functions? First thing is, classification is about predicting categories. You will have category 1, 2, 3 and so on, and you want to predict for each input to which category does this particular input belong to. This is what is called as classification. So whenever you have a classification loss function, it should be such a loss function which will help you in identifying whether the class that you picked, whether it is right or if it is wrong. But in case of regression loss functions, what happened is we were predicting some continuous values. Let us say some value like 1.27. Then what happened? You were trying to see whether this predicted value is close to the actual value. And if it is not exactly the same, then the loss function will tell you how much is this particular value, the predicted value, differing from the actual value. In the lectures, we used y and y cap. Y cap was the predicted value and y was the actual value. What did the loss function do? It was trying to find out how much is this y cap differing from y. In case of classification loss function, what happens? The output of the model, this will often be a probability distribution over classes. Let us say you have different classes, then output will generally be a probability distribution. Then the loss function, your classification loss function, this should measure how well the probability distribution you are having, it is matching the true labels. So let me clarify one thing here. When I say output is a probability distribution, it is not the same with all classifiers. When I'm talking about probabilistic classifiers, they generally output a probability distribution. But there are many other types of classifiers. Let us say something like decision tree classifier or maybe SVM. Or you can also think about KNN classifiers. In these cases, they don't explicitly build a probability distribution. So in these cases, it will be wrong to say that the classifier outputs a probability distribution, but the point is their outputs can be interpreted as probabilities. So that is how these classifiers work. Otherwise, if it is a probabilistic classifier, then it will output a probability distribution. This is how you want to understand classification. What I'll do is I'll just go through the process. Let us say it's a very basic overview. If a classifier is there, this is your classifier, then your classifier will output probabilities. That is after softmax or sigmoid. Then what happens? Then your loss function comes into action. What does loss function do? It will compare the predicted probabilities, whatever this predicted here, this will be compared with whatever is the true label. Let us say you have true label. With the true label, this predicted probability will be compared. Now, if there is a wrong prediction, then you want to penalize this wrong prediction. And what do you want to do? If they are the correct ones, you want to reward it. This is what loss function is for. So you can think of like this, your goal is to minimize your loss. In other words, you want to maximize the likelihood of correct labels. This is what classification is all about. Next thing you want to understand is, generally when you say classification, you can say classification is of three types. One is binary classification. Binary classifications means you have only two classes. You want to decide whether it is class 1 or class 2. That is what you call as binary classification. Another kind of classification is multi-class classification. In case of multi-class, what happens? Instead of two classes, you may have any number of classes, and then each input will belong to any of these classes. Then it is called as multi-class classification. Then there is one more type of classification which is called as multi-label classification. What is the difference between multi-class and multi-label? In case of multi-class, you have multiple classes, but each input X will belong to only one among these classes. But in case of multi-label classification, any particular input X may belong to many of these classes. That is when you call it as multi-label classification. So multi-class classification, you can think of this like multiple choice questions in case of your entrance examinations. And if it is multi-label, it is multiple answers correct question. Or you can say if you are having 4 options, sometimes 3 options may be right. This is when it is called as multi-label classification. In case of multi-class, only one option will be right, all others will be wrong. Okay, so generally classification, you can say these 3 types of classifications are there. When you have these 3 types of classification, then the classification loss function that you should use will also differ according to the type of classification you are using. So here we are actually interested more about loss function because this lecture is more about classification loss function. The reason I explained this part is that I want to tell you what exactly are the loss functions to be used in case of each of these case of classifications. First, if we look into binary classification, most commonly used one is binary cross entropy loss. So binary cross entropy, this is the most commonly used loss function. It is derived from Bernoulli distribution. It is also called as log loss by BCE or log loss. Both are one and the same. You either call it as binary cross entropy or you call it as log loss. Then another common one is hinge loss, but it is generally used for SVMs. There is hinge loss which is used for SVMs. Then you may consider squared loss, but generally it is not ideal for probability outputs. So because of this, in classification tasks, squared loss is not so common. In case of regression loss functions, we explained that squared loss, mean squared error, root mean squared error, those things were very common ones. But in case of classification, squared loss is not so common, but still we'll mention it here. Okay. Next, we'll move on to multi-class classification. In this case, again, cross entropy is a very common loss function in all classification models. So in binary classification, you have binary cross entropy. In multi-class classification, you have categorical cross entropy. So I'll write CCE for categorical cross entropy. This is generally used for multi-class classification, and it is most common when you have softmax outputs. Another one that is commonly used is KL divergence. This is also a loss function which is used for multi-class classification. Another one is again hinge loss in case of SVMs. That is SVMs, if you want for multi-class, you may go for hinge loss. This is another case. Next, let us look into multi-label classification. So here, as I already told before, each example can belong to multiple classes. This is the speciality of multi-label classification. In this case, again, you will use binary cross entropy itself, but with a small catch. The catch is that this time you will have binary cross entropy per class independently. Because you can choose any of the classes, what you will do is you will consider each class as a binary choice. So what will you do? For each class corresponding to each class, you will use binary cross entropy. This binary decision will be whether to choose this class or not. So for each class, you should have separate binary cross entropy. This is the logic used for multi-label classification. So this is a very basic overview of what loss functions you can use. In the coming lectures, what we'll do is we'll dig deep into each of these loss functions, what exactly are their specialities and how they help in each of these loss functions. So we'll go first logically, then we'll go into it mathematically so that you'll understand the concept very clear. So one thing you want to understand about classification is many that is classification loss functions is many of the classification loss functions, they come from maximum likelihood estimate, MLE, maximum likelihood estimate. So deeply about MLE, we'll have a separate lecture in which we'll deep dive into it so that you understand the concept of MLE clearly. For now, what you have to understand is you have to find the correct label. You have to maximize the likelihood of correct label. This is the aim of classification. So for that, you will use maximum likelihood estimation so as to maximize the likelihood of correct labels. For now, just understand this. So I told you that data labels generally follow a distribution. So if they follow a distribution, then negative log likelihood, this of that distribution, this naturally becomes the loss function. Why is it? I'll give you a basic explanation now. The remaining we'll dig deep when we go into, let us say, BC lecture or something. The reason of negative log likelihood is we already told that we have to maximize the likelihood. If you want to maximize the likelihood, first thing is, why are you taking log? Why are you going to log likelihood? For now, you can just understand that log makes your mathematics easy. Mainly, it will convert your products to sums. So in this case, for now, you can just think that log makes your mathematics easy. So instead of maximizing likelihood, let us say you want to maximize log likelihood. So as of now, we reached why we are taking log likelihood. Next thing is, why are you taking negative of log likelihood? The reason is, now you want to maximize likelihood, which would be same as minimizing negative of log likelihood. And this can serve as your loss function, because you should not be maximizing loss in order to make your model better. Instead, whenever you want to make your model better, you should be minimizing loss. So if you simply take log likelihood, you will have to maximize log likelihood so that your model becomes better. Instead, when you take negative of log likelihood, then you have to minimize negative log likelihood so that your model performs better. So then this negative log likelihood can serve as your loss function. In the coming lectures, when we go into BCE loss and all, we'll see exactly what is the negative log likelihood there and how it becomes the loss function.